Hey everyone, welcome back to Jim's Garage. Today I've got an exciting video for you. We're going to be setting up our first virtual machine. Now, why do we want to do this? Well, quite simply, virtual machines are pretty awesome. They give you the ability to spin up virtual hardware, i.e. this stuff looks, behaves and acts as though it's a physical machine. However, it's hosted inside another computer. So why is this a good thing? Well, let's say you have an application that you want to test, but you don't want to test that on your daily driver. You might not be sure how it works. You might not be sure what it does. Therefore, you don't know the risks associated with installing it. For example, you can install that virtual machine. That will give you a clean operating system. At this point, you can create a snapshot, then install your application. If you're not happy with it, you simply roll back that snapshot. It's a single click and it's going to take you right back to that same operating system you had before. This is a really powerful tool and has helped me save so much time. Other benefits of virtual machines are portability. Let's say you spin up your virtual machine. You can shut that down, you can export that, and you can pretty much run that on any other hypervisor on any other machine. So for this video, we're going to be using Hyper-V. Hyper-V is a Microsoft product and it's baked into Windows 10, Windows 11 as part of their Pro or Education or Enterprise offering. Now, if you don't have those, you can buy an upgrade key or you can simply install a trial version of that, which will give you that full functionality. Other options include VirtualBox. This will run within Windows and doesn't have that requirement on Hyper-V. I've chosen Hyper-V because it's simple, it's easy, it's supported by Microsoft, and it gives you a familiar Windows GUI. It's also across all Windows versions. Now, we will be moving on to Proxmox at a later date, but for this video, let's begin. So the first thing you're going to want to do is to make sure that virtualization is enabled. The best way to do this is to go to Task Manager. You want to click on the Performance tab, make sure CPU is enabled, and if you look down here, you will see virtualization enabled. Now, if that says enabled, you're good to go. If that says disabled, then you're going to need to refer back to my previous video where you'll need to go into your BIOS and you'll need to enable VTDX or AMDV depending on what your vendor is. Okay, so let's start. The next step, we need to make sure that Hyper-V is enabled. The best way to do this is to open up your search and simply start typing in Hyper-V. You'll see that the turn Windows features on or off is displayed. If you left click that, you will see in here Hyper-V. You can expand that and you want to make sure that both the management tools and the platform are installed. The management tools is the GUI manager, which is one of the reasons that Hyper-V is such a compelling offering. It also gives you PowerShell, which PowerShell gives you advanced options within Hyper-V that you can't necessarily do through the GUI. We won't be focusing on those today or in future videos simply because we'll move on to Proxmox. But if you are familiar with PowerShell, this will give you a much easier idea of how to pass through devices, GPUs, etc. And the Hyper-V platform itself. So this is actually the bit that enables the Hyper-V platform. So we want to tick that. You can see all of those are ticks. You want to hit OK, and then it's going to ask you to reboot. So let's go and reboot. I'll see you soon. And through the magic of editing, we're back. Now, I'm going to load up Hyper-V. It's as simple as typing Hyper-V, and there you'll see Hyper-V Manager. This is what we want. So we're going to click that, and we'll open up the GUI. Now, before we get to play, I'm going to talk to you a little bit about what this is. So Hyper-V Manager in Windows is a Type 2 hypervisor. A type 2 hypervisor is a hypervisor that runs within an operating system. This is different to a type 1 hypervisor, which runs on bare metal. Now, I'll give a quick summary on the screen of why that's an important distinction. Typically, it's down to system resources, and you're taking out that OS layer of abstraction. That's better for both performance and reliability. You can check out more in the links below. So, let's get on to creating our first machine. First thing you're going to want to do is download a Windows ISO or a Linux ISO. Choose what you want to do. I'll demonstrate both, but the process is absolutely the same. So, with your ISO downloaded, let's extract that. One thing to note is the quick create on the right hand side. If you click that, you'll be presented with a wizard which comes up with a couple of versions of Windows and the latest 3 long-term support versions of Ubuntu. Now, the Windows image for Windows 10 is okay, sort of 4.36 gigs. That's a standard image. The Windows 11 one is quite bloated at 20 gigs because it's a development environment. So it might be useful if you're going to do some development, but you're probably not on this video if you're already a developer. The other 3 are standard Linux images that you can get from Ubuntu's website. So those are actually pretty good out of the box. So feel free to go and install the VM through that route. But going back to the manual process, because I think it's really important you understand how you set this up. One of the first things we want to look at is to look at the virtual switch manager. So just like a virtual machine, you're running what is effectively to the machine its own physical machine on another machine, virtualized. You can do the same thing with a switch, and I touched on this in the last video as to why this is important. So let's actually demonstrate what you can do. So the default switch, if we click on that, what that is doing is sharing the NIC, that network interface card, on your host device. So all of that traffic on all of the virtual machines will come from that same device. What you can also do is create a new virtual switch. So what this does is effectively chops your NIC up into smaller virtual NICs, and it acts as though it's almost a physical NIC on that new virtual machine. So this is useful for doing things like giving it its own MAC address and its own VLAN tag for when you want to segment that network. It also means it's not sharing the host's resources in the same fashion. So we won't touch on that for now. We'll come back to that probably later. So if we create a new virtual machine, we're presented with a handy wizard. So we want to click Next. We'll give it a name. Let's call this one Windows 11. You can choose where you want to store it, but for all intents and purposes, that's a perfectly fine location. Now, there's 2 generations that you're presented with. You can go with the generation 1, which is kind of the old generation, or you can go with generation 2, which has newer features like a UEFI based firmware. So for the sake of this video, let's go with generation 2, because Windows 11 has a number of features such as drive encryption, etc., and TPM modules that need a generation 2 machine. Be mindful that some operating systems, some of the Linux ones, will actually mean that you need to do a generation 1 if you're sticking with Hyper-V. This won't be a problem as we move on to Proxmox. How much RAM do you want? How much you got? Just like a physical machine, the more RAM you give to a virtual machine, the more resources it has available, the snappier it will feel, etc. One thing that's important to note is dynamic memory. So you'll see here, this is startup. So when you start that VM, it's going to give it 4 gigs of RAM from the start. So as soon as you click go, that's 4 gigs of your host's memory that's taken up. If you tick dynamic memory, basically what will happen is that VM will be much like your host. So if it requires above 4, it's going to keep taking it. So I typically turn this off because I want to peg it at 4 gigs. So that means it won't use any more than 4 gigs of memory. Now, this touches on the previous thing we mentioned with switches. So what do you want to do with your network? So you can decide just to not connect this to your network. That might be a good idea depending on what you're trying to test. If you're testing something you don't trust, you probably want to put that into a virtual machine first, have a look at it, feel comfortable with it before you put that on your network. If, like today, we're just doing Windows 11, we can probably trust that, so we can stick that on our default switch or a different switch that you've created. So we click next. So, just like a normal computer, it needs a hard drive, in this case a virtual hard drive. And as I mentioned earlier in the video, this is kind of where the beauty of the virtual machine comes into play. Your hard drive is basically a file, and you can move and back up and export that as you see fit. So the default is 127 gigs. That's a bit big for this video. Let's tame that. Let's put 40 gigs. You will note that you can use an existing virtual hard drive, or you can even specify one later. That's right. You're effectively building a computer as a template. So much like a physical computer, you can build the hardware and then you could stick a drive in afterwards. The two things are independent, and that carries over into the virtual machine world. So let's create one because we don't have one. So let's click next. Now it's going to ask where's the operating system. So we've already downloaded that ISO. So we tick the middle option. Do note as well, you can install from a network, which is a really cool feature if you have that set up. We might get onto that later. Let's click browse. Let's go to our desktop. Let's find that Windows file. Let's click open. Let's click next. And so it's given us a summary here. So what are we doing? Windows 11, so generation 2. It's got 4 gigs of RAM. We're using that default switch, which means it's going to share the host's NIC. We've stated where we're going to store that drive, and we've specified where the operating system is. Let's finish up. So that was super quick, and as you can see here, we've now got our Windows 11 machine. Is it running? No. All of these values in the table are blank. So how do we start this? So you can just go ahead and click start and that will work. However, I like to click the connect button, which will bring up this window here. And now, just like you've got your machine at home, if you click start, that's exactly like hitting that power button. So let's press it. Hit space like you normally would. And voila, this is behaving exactly like a physical machine would. So let's go and install this. And just like that, in under 5 minutes, we have a working Windows 11 virtual machine running on Windows 11. Pretty cool. So that's going to wrap up Windows 11. As you can see, it's running. We can log onto here. We can start browsing the internet. We can use this just like a normal machine. Okay. Now I mentioned earlier, one key feature of virtual machines is the ability to do a snapshot. What does that mean? So let's put that into practice. So we've just installed our new fresh operating system. Now, before we try out our application, we want to back this up. So we've got something that's recoverable should anything go wrong. So it couldn't be simpler. Click on the Hyper-V Manager, make sure your VM is highlighted, and simply click checkpoint. You can see here it's creating, and bang, right there we've got our checkpoint. So let's try that out. Let's download 7-zip. We download 7-zip. We installed 7-zip exactly like you would on a normal machine. That's now installed. Let's test that. Voila, there's 7-zip. Okay, say this was something nefarious, we didn't want it, or we just want a clean OS. Let's go back to Hyper-V Manager. Let's make sure that our restore point is selected. And let's hit apply, and let's see what happens. We want to apply that. As you see, the old session closed down. You can see in the background it stopped and it started. Let's reconnect. We sign back in. Let's try and open up 7-zip. 7-zip's not installed. Boom. You've just seen the power of virtual machines. Okay, excellent. We've got a virtual machine running. Let's step it up a notch. Let's move on to Linux. That's where we're going to be heading in the future. So, we're going to leave this one running, just because I want to show you sort of parallel virtualization. We're going to go through the same process. New, virtual machine. Next, we're going to call this one Ubuntu, for an obvious reason. Now, Ubuntu does work on a generation 2, typically because Ubuntu Desktop has a lot of those newer features. We'll untick dynamic memory. We'll keep it at 4 gigs. Make sure this is something that is sustainable on your machine. Like, if you only have 4 gigs on your machine, remember that you're running Windows 11 or Windows 10 or whatever you're running in the background. Plus, you've currently got a VM running, which is assigned 4 gigs. And you're looking to do another 4 gigs. It just won't work. So do make sure that you scale these values in line with what you are, what you physically have in your host. So I'm okay. I'm running 16 gigs. Another 4 won't make it sweat. We'll stick it on the default switch again so we can do something fun with the internet. Again, we'll tame this down. Ubuntu is a lot lighter than Windows. We'll give this one 20 gigs. We're going to create that. This time, we're going to select that Ubuntu image. There it is. We're going to hit next. We're going to finish. It's doing its magic. It's created it. And you'll see here, we still have Windows 11 running. Let's go ahead and start the Ubuntu installation. So one thing to be mindful of when we're doing this, and I think I mentioned it earlier, is around that generation 2. So that typically runs things like the trusted platform module, which is a way of the computer of identifying itself, and it's used for things like disk encryption. So because this is a virtual machine, we're going to want to disable that feature just for this tutorial. We will be making use of that feature in Proxmox at a later date. So if we hit that machine and go in settings, this is a really good way of seeing everything that we set up within that wizard. But for this bit, we want to go to security and we want to untick enable secure boot. We want to hit apply. Then let's connect to the Ubuntu machine and let's click start. Voila. Let's do an Ubuntu install. One thing you might note when you're installing, it often asks you to remove the installation medium, much like on a physical machine. So the way to do this, just simply move that window to the side, go back to your manager, click the settings, go to the DVD drive and just remove it. Hit apply. OK. Go back to the VM and then just hit enter. And there we have it. Ubuntu running on Windows 11. Both of these operating systems are fully functional as though they were in a physical machine. One thing you might note is the smoothness of these VMs. So the Windows 11 VM, really smooth. The mouse, you can see, well, you can't see because I've disabled, but the mouse is very smooth and it has hardware acceleration. So what's actually happening here is, I've mentioned before hardware pass-through. That's pretty much what's happening here. Because it's Windows in the background and Windows in the VM, it knows how to hardware accelerate this machine. If you flip to the Ubuntu machine, you'll notice that the mouse cursor is quite jerky. Hardware acceleration isn't enabled on this device. That's because of the drivers that are installed within the virtual machine, it being a Linux kernel versus a Windows kernel. Now in future videos, we'll look at how you can do hardware pass-through to make it a smoother, more natural experience. Okay, and there we have it. I told you it was simple. Now that we have our virtual machines up and running, you're pretty much good to go in terms of playing with applications, trying things out, all within a sandboxed environment. Worst comes to worst, you can roll back that snapshot, or you can simply delete and reinstall the VM. That simple. Now in my previous video, I mentioned about how do you connect to these remote machines. Now it's quite simple if you are on the machine where these virtual machines are hosted. However, you might want to connect remotely to these. So how can you do it? Well, if you're used to RDP, the remote desktop protocol from Microsoft, then the same process applies. Just as you would RDP into a physical machine, you can also do that on a virtual machine. So I've gone into the network settings here on the Windows 11 VM. And as you can see, it's got an IP address. And as I've demonstrated, we can connect to the internet, we can check out, download, install, all of that good stuff. However, this is an internal network range. So what's happened here is within Hyper-V, it's created its own internal network. Now this network only allows the VM to communicate outwards. We can't actually route from our host machine, this is the one where I'm running Hyper-V on, to this address. It doesn't know what that is. So how do we solve that? Now to prove that, I can go to RDP and I can type in that IP address. And if I hit enter, it can't route it. It's not going to find it. So how do we solve that? The answer is to go back to that virtual switch manager that we had before. So let's turn off our virtual machine. That's as simple as shutting it down like you would a normal computer. Should be pretty quick because everything's virtualized. So now let's create a virtual switch. Now this is the key bit. We want to make it external. So this gives it an IP address on your network. So wherever your switch is, wherever your router is, this will create a DHCP entry. So let's create that virtual switch. So it's just called new virtual switch. We can call it external. That's probably a better name. Now we want it to be external. It's going to use the network interface card that is on my machine. We can allow the management operating system to share this. Generally, we don't want to do that because you're kind of bridging networks and that goes against sort of security good practices. We'll leave it enabled for this because it doesn't matter, but in later videos you might want to disable this. So let's apply that. Hit yes. Okay, so now we've got two virtual switches. So what we need to do is click on our VM, hit the settings, and change the virtual switch from the default to the external. So let's see what happens. Asked to verify the certificate because it's self-signed. We don't care about that. Yes. And there we go. We're on the virtual machine over RDP. This is awesome. On the next video, we're going to be installing Docker on to our Ubuntu image, but we're going to tweak that slightly. We're not going to be using Ubuntu desktop. You can if you want to, but we're going to focus on Ubuntu Server. So your homework for this video is to take everything you've learned and install Ubuntu Server. Go to Ubuntu, download the server image, and follow the exact same process as you have done today.